François Vaudrin, and we are very happy with my son Mathieu Vaudrin of Semaphore.ai to present you our project and to participate to the ninth conference of SUMO user. We are in Quebec City in Canada, the beautiful city of Quebec. This is an area, a region of around 600,000 people, and it also has several university and research center. Okay, according to a study. Okay, just before we will present ourselves shortly, I have around 30 years of experience in the Ministry of Transport of Quebec. I was working in road preparation and building road. And I also have a PhD in computer science in the field of circulation. And Mathieu is a mechanical engineer, and he has also a master's degree. He has experience in simulation and modelization. The motivation of our project is because the traffic congestion in Quebec, province of Quebec, is a very big issue. It's one of the most important problems. According to a study realized a few years ago, it costs around $1.5 billion every year for the cost of congestion. This is because the people waste the time in the traffic. There's also cost of for the energy and the pollution. And the rush hour is getting longer and longer, and there is no space to build new roads. So it's important to find a new solution to reduce the impact of traffic on the life of people. Also, we have to take into consideration that there's a lot of transportation by truck, and there's a lot of truck that add in the network. So we need these transport because it's very important for the economy, but it gets the situation worse for the traffic congestion. Why the heavy vehicle have impact on traffic? We think, first of all, they are bigger than passenger car, maybe 4 times. And also, they are more difficult to manipulate, to drive. And they accelerate, decelerate less fast than passenger car. So they reduce the road capacity. Another effect is the stopping distance because when a trucker drive a heavy vehicle, it takes more space to be able to stop. So, and there's also another aspect that is important is the lag, the brake lag at the right of the in the title. The brake lag is the time that it takes from the moment the driver push on the brake and it reach the end of the brake system at the rear of the truck. So it had to the stopping distance. So what we are trying to do in our work is to find the link between the duration of the rush hour and the number of heavy vehicle on a road. And what we wish to do after, eventually, it's to be able to suggest practical improvement for the situation. And we are very fortunate to be able to use a SUMO to make the simulation, the scenario, because here in the province of Quebec, there's a lot of discussion, but there's not very much scenario of amelioration with the simulator. There are two steps in our research. First of all, we reduce the complexity of the network, and we isolate a section of the network, and we took the Pierre-Laporte Bridge. It's a bridge in the Quebec area with very jam every day. So it's a good place to make our research. The Pierre-Laporte Bridge you see on the photo is a very there's a lot of jam every morning and every afternoon, and the situation is worse and worse. It's a three-lane highway, and there's a bottleneck on the bridge, and there's three entrances on each side to take the bridge. So it gives a lot of traffic to the bridge every day, and there's no solution in sight. So what we want to do in the first step, we take a 3-lane, and we will run the simulation for 2 hours, and we try to add to the maximum of the road capacity, and theoretically the road capacity of one lane on a continuous flow, it's 2,000 vehicles per hour. So with a three lane and 2 hour simulation, we want to let 12,000 vehicles to pass on the bridge. And what we are doing is to vary the number of heavy vehicle compared with the number of car at every simulation, and we keep also the same amount of vehicles. So if we remove some car, we will replace these cars by heavy vehicle, and we see what happened. And at the end of the simulation, we are checking how long it takes to empty the network. Okay, the principal parameter that we are using is naturally the length, that difference from the two vehicles. The minimum gap, we took 10 meters. It was an average because it's difficult to, because the gap is varying depending the speed. We have a little, the speed is a little bit lower for the heavy vehicle. The acceleration, the sigma is the imperfection driving. So we decide to let the passenger car with a little bit more imperfection. The TOW, the TAU is related to the perception reaction time, and we take 3 seconds for the heavy vehicle because the brake lag that I was talking before. And that's the principal parameter that we are using. Naturally, we can use other parameters, but it seems to us that it's reasonable. And we have also discussed with the truck driver with experience, and it's around these parameters that was maybe the best for the first ride. also, okay, this is our result, and you see that it's a little bit strange and surprising for us that it's like a linear relation. When we had a vehicle, probably it's because there's no stop at the end of the simulation, and it's a freeway. So we think that if you have put more artificial jam, that the difference would be worse, but it gives a good idea of the importance of heavy vehicle. For example, if you take 15% of a vehicle, it extends the simulation for almost 1 hour, so 50%. And if you take a rush hour of 3 or 4 hours, like in the reality, so it could have a big impact. So for the next part, Mathieu will show you our network.
Thank you, François. I'm showing you our network simulation. So here it's, I'm gonna take this one. So here is our network simulation of Pont Pierre-Laporte Bridge in the Quebec area that link the two shores. So in our simulation, if I start it, we see passenger cars and trucks that crossing the bridge between the two shores. So as you can see, if I stop the simulation, trucks takes more spaces around the cars. And also there's a little bit of spaces between trucks sometimes. We think because it's about the speed difference between trucks and passenger car. Trucks goes 10 kilometers less than passenger cars. So, and we let it, that simulation runs for about 2 hours. And we see the result if we were able to pass all the vehicles, 12,000 vehicles. But you see, if I run it until the end of the simulation, I take the other simulation for that. It will be faster. So at the end of the simulation, there's the cars in are still on the bridge because the simulation in 2 hours didn't have the time to let cross all the vehicles. So if I let go the passenger trucks crossing the bridge, is going to amount for about 3 hours, and we take that value and put it on our graph to trace and see what's happening. So our final result for this simulation is 10,118 seconds. Thank you. So I let I pass the speech to François again and return to the presentation.
Okay, thank you, Mathieu. And we made a lot of other tests, but it's the beginning of we have some data now. We can go further in our research, and our next step that we intend to do is to expand our network and to use the data that are available by the Minister of Transport of Quebec with the flow rate every day of the traffic flow that cross the bridge and the different study, and we will be able to replicate more precisely the vehicle that are going to Quebec and the other side every day. And what is interesting is that that give us a model to with SUMO that will help us to propose eventually a solution, and naturally we will need the collaboration of the decision maker and government, because there's a lot of discussion around this issue in Quebec. That's our presentation, and we want to thank very much DLR and the SUMO team for their support. We appreciate very much the support of SUMO team and Jacob and all the people that working on SUMO. And if you have a question, we are ready to respond with the few minutes that we have.
Okay,